Let's welcome Casey Gray.
All right, so I figured coming to this presentation with a bunch of engineers, I might as well talk about theory versus reality after living in a passive home. So before I get into all of that, and I'll ask if everybody knows a passive home, essentially this is me in a nutshell. The reason I do what I do is because of the people you see in that. I am obviously an adventure seeker as well. The van is what slows me down. It's not electric. Maybe one day it'll be electric. I do race the Volt though. I have done that and that has been fun. So I can attest to all of that. But my journey around the sustainability really started with the little guy there. And when he came into this world, that's when my whole mindset changed. So that's why I think it's important to show this slide, because now I'm thinking about the future. Is anybody here, is everybody familiar with Passive House, or should I say, has anybody not heard of Passive House before? So essentially, most of you have heard of it. Passive House, it's actually a certification. So if you go through the certification process, it's modeled, it's one of the most rigorous building standards in the world. So if you want to go through it, they don't really care about the products that you use. They care about how your house performs. And this is the basics to it. So if you can orient your house properly, you can gain from the solar, you have all of your living spaces on the sun side, you want to make it as airtight as possible. You have super insulated walls, high performing windows, and then you mechanically ventilate your whole house. So when you make it really airtight, you need to make sure that you're bringing fresh air into that system. So that's basically how, in theory, a passive house would work. I'll get into what worked and what didn't work when we built our house. But this is the 5 most important factors. So I've reordered this since I've done presentations over the last few years, because I think it's most important to, when you're designing, building a house, to think of these things in this order. So if you can start with the envelope being your walls, your roof, your windows, doors, that sort of stuff. So your wall assembly is going to be your R value and your air tightness. Your windows is going to be how well they perform, where you place them in the house. Are they on the north side, the south side, east, west, that sort of thing, right? Because you can only block the sun on the south side, and you can't really block it on the east and west unless you're getting into shades that are moving and so forth. And then you never have to worry about sun on the north side. Fresh air system becomes extremely important when you build a house. And the overhangs if you can, and orientation if you can. And I'll get into some of those areas, because once again, if we can all do it perfectly, I'll explain what I think, but everybody wants something different. You want to make it look good, just like electric cars. If it doesn't look good, people aren't going to buy it. So we've done now 5 passive houses around the city for different architects. And we started, the first one that I had done was for ourselves. So we tested it on our own house. And we wanted to do something that wasn't reinventing the wheel. So we weren't reframing a whole house in a completely different way. One of the concepts behind building a super insulated wall is you have to really understand building science. And a lot of the people that you'll talk to say to put the load-bearing portions towards the inside, which makes sense, because if you ever have any moisture issues, you won't really know if it's on the outside, and there's the possibility of it happening is going to be higher on the outside. I decided to put it on the outside because of the constructability, and we actually started building this house in November. And I remember when we built this house, we were building an R2000 home at the same time. We basically got the foundation in, put the insulation down on the slab, and it snowed and it never stopped. So we wanted to get it closed in as quickly as possible, and that's just a reality of building in our climate, right? If everything was perfect, we'd be starting construction in the spring, and all of our houses would be closed up by the time it snowed, and we'd be doing all the interior work, and it'd be perfect, right? But unfortunately, it doesn't work like that in construction, or anything really, but that's besides the point. So here's what our wall assembly ended up being like. I ended up with about R73.5. So to give you an idea of what that is, if you're not 100% sure what that is, if you were to buy an older home, for example, like 2x4 construction, if it has insulation, you might have R12 in there. Houses nowadays, minimum building code, there's different building packages, but typically the building code now is R24. And what they're doing is they're requiring you to either go with an R24 bat, which is more expensive, or usually you do an R22 bat and you put 1 inch of exterior insulation and you get rid of the thermal bridges. So things are changing. So the way the building code is going, they're saying that all houses need to be net zero by 2030. We'll see if that actually happens. Once again, it's the economies of scale. How do we make it cheaper? I think the bigger problem is how do you train people to build better? Because there's a whole lot of people that need to put these houses together. And we need to make sure that they're putting it together properly. And then what do you do with all the houses that are already built? That's not going anywhere, and that's where the majority of our housing is right now. So the way we got our R73.5 is we did 2 inches of insulation on the outside and then a typical 2x6 wall with an R22 bat. So that was our structure. And then once we got everything air sealed, on the inside of that we have a 1/2 inch Excel extreme sheathing, which is our air barrier. And then we would do that, so that would be here. So I'm talking from the outside here. So this is the 2 inches of rock cell here. This is our 22. There's a space after we put our inside wall. So this is all load bearing stuff. We were able to build the whole house. And then after we had the roof on and after the air seal and everything was done, then we could do all the stuff on the inside after the fact. We also went with rock cell in this case, which is now rebranded to rock wool, I believe. Because there's no fire retardants, it's rock. It's naturally going to prevent any fires, not catch on fire because of the rock. If it gets wet, it doesn't lose its R value. It can dry and it's totally fine. If fiberglass gets wet, for example, it's garbage. You might as well throw it out. Mold's going to grow on it, lose its R value. So we wanted to prevent when moisture gets in there, because it probably will at some point. A mouse chews a hole through something. Who knows what's going to happen? So we went with rock salt.
Where's your vapor barrier?
So the vapor barrier, I'm actually going to talk about the difference between an air barrier and a vapor barrier as well. In this case, our vapor barrier ended up being on the inside, but our air barrier is taken care of here with this 1/2 inch Excel extreme sheeting, which is a fiberboard. And then we have our weather barrier here on the outside. So we, instead of doing our air barrier and our vapor barrier, which you typically see in construction now on the poly, and then that gets taped, we separated them. So
It's on the inside.
it's on the inside, yes. So this would be after we frame the exterior 2x6 wall, so this wall here, and after we sheathed the underside of the trusses. And we sheathed it and we taped all the joints because we wanted to build a chase below that, because we had to run ductwork for all of our ventilation system, and we had to run electrical and pot lights and all sorts of things. And we wanted to make sure that we weren't penetrating our air barrier. So our air barrier on the roof side is actually the OSB, which is also our vapor barrier. So if you go with 5/8, some actually 1/2 inch OSB or 7/16 OSB can be vapor barrier as well. And then we taped all the joints. This is the Excel extreme sheething you see here, which is typically used on the exterior of buildings. We used it here because it's permeable. And then we taped everything from there.
What was the overall thickness of the wall from the wall?
If you count the masonry, we're about 2 feet. Without the masonry, about 19.5 inches. Which ends up with really nice window wells on the inside if you keep your windows towards the outside, which is part of it. No, everything we did drywall returns, right? These are all construction things to consider once you start going through it. And this is part of the how do you train people to build houses like this, because it's not cookie cutter type stuff. So there was definitely, even now, like we do custom, so we're used to it. And the guys are always saying, well, this wasn't on the plan. It's like, you guys are used to this. We deal with it on the site, right? Because things are going to be missed, and we just need to deal with it when we come across it. So this worked really well, though. So pre-drywall, Stefan was supposed to be here anyways. He's our energy modeler. I don't see him. But we got 0.56 ACH, air changes per hour, pre-drywall with this. Passive house needs it to be 0.6 or less. This same wall assembly got us 0.44 on the house after it. And actually, when we did our pre-drywall test on this house, which we didn't have we had 23-foot wide windows. We didn't have those in, so we just had like poly, and I think on the bottom in the basement we had like 6 guys sitting across the bottom of the tarp. Anyways, that's construction. Windows didn't show up on time. So here's the difference between air barrier and vapor barrier. This is really important when you get into building science, is that if people don't understand the difference between a vapor barrier and an air barrier, there could be some issues there. So the building code actually requires your air barrier to be continuous, which in theory it isn't, and it's never been done ever, because if it was, you'd have an ACH of 0. And to my knowledge, nobody has ever done that anywhere in the world. So the air barrier needs to be as tight as possible, but if you take care of that air barrier somewhere else in your wall assembly, your vapor barrier does not need to be continuous. So we did not have to tape so this was our air barrier, which ended up getting taped. You can't really see the tape there because it's white as well. The vapor barrier just went on, and then we did actually a strip of what's called certainty membrane, spelled membrain, and it's a vapor permeable. So it allows if vapor pressure builds up on one side or the other, it can actually travel through it. So if there was any moisture in the wall, it could dry towards the inside or the outside. So windows, this was the concept of our house before we actually got to it. I'll show you pictures of it done. But when you're thinking of windows, the spacers are extremely important. The spacers are what holds the glass apart. So if you're ever shopping for windows, if you're living in an older home and you're getting your windows replaced, be sure you ask for super spacers instead of aluminum spacers so that you don't get that thermal bridge coming through that. One of the things that we obviously knew about this going into it, but these back windows, you can't tell here. I'll show you on another picture. But they're about a walkout basement. There's a 23'4", and we had to carry masonry across that opening. And the reason we had to do masonry is because the area that we built the house in had a covenant for brick, stone, or stucco on the exterior, and I am not a fan of stucco, so we went with brick. So we had to do big steel beams and lintels and all sorts of other complicated things. And we actually ended up having frost on the outside of our windows at one point, and that was new to me, and I'm like, oh, what's going on? Call my window guy, and he's like, don't worry, that's actually a good sign. That means that your windows are performing, right? Because we don't have the heat loss. So frost can build up on the outside of your window. That means you don't have that heat loss coming from the inside, just like frost builds up on your car or anything else that's outside. So we actually had that happen quite a few times. And now when you have your ACH at so low, you want to go with something that, this is essentially, like it says, I can't really read it here, but it says the lungs of your home. So when you make your home tight, you need to make sure that the fresh air can actually come into it. And this makes for a comfortable home. I'm also a fan, has everybody heard of HRVs? Anybody not heard of HRVs? What about ERVs? So E actually stands for enthalpy. Usually people call them energy, but people don't know what enthalpy means, so they started calling them energy. But these are actually ERVs, and they allow the transfer of humidity through the core. An HRV has an aluminum core, and I'm actually not sure what the material is in these cores, but it'll actually allow vapor to travel through. And these can run 24/7, whereas HRVs technically shouldn't be ran in the summer because that hot, humid air from outside is being pulled into your house. Now, in theory, you don't really want to run that in the winter either, because then you have that dry air coming into your house if you need moisture in your house. So actually, a good ERV, which all the typical manufacturers doing at Van E, Life Breath, they're all doing good ERVs now that don't freeze in our climate. The issue with ERVs at the beginning is that the cores were freezing, and our cores actually froze at the beginning. They weren't supposed to, and then that's why they weren't working for our climate. So and then you can go high, and I won't get into all the different manufacturers, but I definitely recommend ERVs and run them 24/7. This kind of gives you an idea of, I had said that we were doing a chase below our roof trusses. This is all the ductwork that we had. So our whole house, to give you an idea, our house, as I say was, because we actually sold the house last April. So our house was 4,000 square feet with a big, great room, 17-foot ceilings in the middle of the house. The whole house only needed 18,000 BTUs, in theory, to heat. A typical house that size would need about 90, I believe, built to minimum building code. So we heated the whole house with air source heat pumps. We were fossil fuel free as well. We got on the microfit. We had solar panels on the roof. I'll show you some numbers for that. But one of the things we did to keep the house airtight is that we eliminated all of our fans. So no bathroom fans, no range hoods, and our dryer didn't vent outside. So no range hood, people have done that, not a big deal. You put it in charcoal filter, if you do a lot of greasy cooking, maybe you don't want to do that. Convincing people not to put bathroom fans in, that's usually where I get some pushback. However, all of the bathrooms have exhaust ducts, and they all have booster switches. So the idea is, when you turn a fan on, for example, say you weren't running it through your ventilation system. If you turn your kitchen range hood on or your bathroom fan, that's sucking air out of your house. And that air has to come into your house somewhere. And that's going to come in just through leaks and holes and anywhere that it can in your house. So by eliminating those, you actually precondition the air that comes into your house. So if it's minus 25 outside, 20 degrees or 22 degrees inside, and you turn on your booster switch, it's actually going to go through the core, and if your core, or through your fresh air system, if it's 92% efficient, you're actually preheating the air with the air that's leaving the house as it's coming in, as opposed to bringing in minus 25 degree air outside. So to give you an idea, I won't go through all the math on this, but I can obviously share this with everybody. I think you get a copy of it on the website. But to give you an idea, say you did put a big, people love when we redo kitchens, they love the big kitchen range hoods. If you put 1,000 CFM fan in and you run that, you could lose, based on being minus 25 degrees outside and 22 inside, you can lose almost 90,000 BTUs by running that fan. So that's energy that you have to then use to reheat your house. So however you're heating your house, that's just adding more energy, whether you want to call it money, you're adding to the energy grid, however you're heating your house. It's definitely not a good thing. So the next thing would be overhangs. If you can do overhangs, you can design it. Great. The issue is trying to get rid of thermal bridges is important. And when you're adding exterior insulation, I mentioned we put 2 inches of insulation on the outside. You have to attach structural members to that somehow. So you end up with details like this, where you have like a 2x6 and you attach a roof to. These are all the little details that you need to have everybody working together, which makes it a lot more difficult to do details like this when you're building houses by the hundreds every year. Easy to do on a smaller scale, harder to do on a bigger scale. Obviously, if you can get good orientation, great. I'll explain why I put this in this order later. We were lucky enough, we bought our lot knowing that we could face the house directly south. So we angled it to get that full southern exposure. And one of the things that I didn't tell you, I actually had 6 feet of peat moss on this lot, so I basically blew my budget before I even had a foundation. But that's beside the point. It did work out really well in the end. But yeah, we had so much peat moss on our lot that we actually had a high hoe get stuck. We had to get a bigger high hoe to come and pull the smaller high hoe out of the mud. But I don't think my excavator let that one down for a while. But this was the finished product. So you can see this is back of the house. These are the 23-foot windows I was mentioning. This here actually, from here to here, is all open on the inside. We have pictures on our website if you want to see interior shots. But we pretty well designed this house exactly the way that picture was at the beginning when I showed you. So all the bedrooms, we had 4 bedrooms, so each window here is a bedroom. This is another bedroom down, which is actually my office, but turned it into a nanny suite. All the living spaces have glass that's facing south. And then we have the garage. You can't see it, but these windows here actually go in the garage. It's a side entrance. And then you can see the front, smaller windows, overhangs everywhere. We basically took a box because that's the most efficient shape, and we tried to make it look good, and we put all the overhangs on, and they were sized accordingly to block the sun depending on the time of the year.
Next question, what's so important with all the overhangs?
On the east, west, and north sides, nothing. It just looks good, and it was nice to have a wraparound. On the south side, it actually blocks the sun in the summer months. But then when the sun drops in the colder months, then it allows it in. So you can see this overhang up here, although it doesn't look like much, because these windows are 3 feet off the ground, it actually does do something.
How big is the overhang?
This overhang here is, I think it ended up being like 6'6", I believe. It was 8 feet originally, and then we pulled it back once we modeled it.
The top floor?
The top one, I believe, was 18 inches. So, but that all gets calculated too, right? So this could be less if it was closer to the top of the window. And then the other thing too is that we had our windows towards the outside. If you set your windows more towards the inside, that gives you, like, the sun comes in less as well. right? So it all depends on, and these are all things that need to be modeled and put into the software. I don't do any of the modeling stuff. We get somebody else to do that. We just work on the building side,
So is
figure
there
out what's working.
preference on most housing to do the windows on the outside?
It depends on the modeling. We wanted the big windowsills. That's why we did it. Usually when you get into passive house certification and passive house certified windows, most of them are European tilt and turns. So they swing in. So if they swing in, then it's hard to make use of that windowsill wherever it's an operating window, right? So we ended up going with casement on purpose. And then this another example, I'm running out of time, so I won't go through everything, but this gives you a good idea of how we built it. Once again, you can kind of see that it's exactly like the first picture that I showed you. This would be the south side here, all of the windows, and then smaller windows on the north side. And then we basically had almost no windows on the east and west side because you can't block the sun on those sides at all. I won't get into it, but we did do like a version of Swedish platform framing. So typical construction is you have your foundation, you sit your floor on your foundation, you sit your wall on top of that floor, your next floor sits on top of that. The issue is that becomes an issue with the air barrier. So this red line that you see going all the way around is our air barrier. And the trick is, how do you make that continuous? We ended up hanging our floor joists after the fact. So once again, another detail that we can do, but training somebody else can be difficult. So this is where we get into a little bit of theory. This is the new ENERGUDE rating system. Has anybody seen the new one? You might have seen the old one, which is a scale from 0 to 100, and you have no idea what the number means because it really doesn't mean anything. But anyways, the new system that's now out is the lower the number, the better. So this was actually my house. It's supposed to be 0. So in theory, I was living in a net zero home. In reality, I was not. And it was a big house, but there was only 3 of us. We had Airbnb, had the office. We'd do some work there. And the house was never really fully done, so we were always working on the house. So there's tools running. But this is before I got the electric car. So don't worry about the dollar. I was making money just because I was part of the microfit. But we were almost net zero. And that we didn't have any natural gas, so that's hot water, that's air conditioning, heating, that's everything. So it was pretty close. Now, we weren't net zero. If you were to do it month by month, in the winter months, we were not net zero. In the summer months, we were producing way more, right? But we were on the grid because we were selling it back through microfit. Now, when we added an electric car to the mix, we were basically double. So our costs didn't really go up that much, but we were using a lot more electricity. So that's one of those things where theory versus reality is important to know, right, in testing these things. Because as soon as you throw humans into the mix, it throws everything off. Because you don't really know, you can't predict any of us, right? So, or how we live, and everybody's different. And there's been studies done where they try to model the same house, but then one house ends up being the laundromat for the whole neighborhood, and that throws everything off, right? So there's all sorts of things.
Question.
Yeah.
Your solar panels, were they all photovoltaic, or did you have thermal panels as well to produce hot water?
No, they're all PV. And then we had an air source heat pump hot water tank.
You didn't take any advantage of solar heating?
No, I talked to my plumber about that, and one of the things is I didn't want to turn it into a science project and scare people away, knowing that I would probably be selling it. So by putting less, I wanted to use technology that was readily available and easy for people to fix. And the solar hot water didn't really make sense cost-wise for me, with the solar panels producing the energy and using the air source heat pump hot water tank.
That goes counter to experience that I have with my brother, who does a mixture of solar thermal and solar photovoltaic. He gets a lot of heat from his solar panels.
That he heats his house with or heats his water with?
He heats his underfloor heating with.
Oh,
Low-grade heat.
yeah, we didn't have radiant. So we were heating with air source heat pumps. So the only thing we would have been doing is heating our hot water tank with it.
Did you think of making the building a LEED certified?
Yeah, I just didn't go through the paperwork and the cost of doing that. I would probably be. I don't think I'd be LEED Platinum because I'm not close to bus stops. The thing is, I'm not. I like LEED and it focuses on materials, but you get points like being a carpenter by trade. You know, the LEED Platinum building for the trades at Algonquin is great, but you have a wood shop that's full of glass and no parking for any of the tradespeople, right? So there are some things that just didn't make sense. I'd probably be LEED Gold or something, but I didn't actually talk to Stefan about doing that.
You said you're using air source heat pumps
Yes.
in the winter?
Yes. Mitsubishi's units now heat to minus, they're efficient to minus 27.
How efficient?
I'm not sure what the percentage is.
Down to a couple, less than one or more than one?
I'm not sure. If Stefan was here, I'd be asking him for that. But I know I can tell you that
What kind of refrigerant is in there that works at that level?
I'm not sure what they're using. I don't know the specs on the refrigerants or anything.
Complex.
So ours were working to minus at the time. They said to minus 25. So the new ones say minus 27. Those though we never had. So the thing is, when it's really cold, it's typically sunny out. So we would get all the heat from the sun because of all our south-facing windows. Now, one of the big lessons I learned though in having all those windows is that I couldn't regulate temperature. So it is possible to overglaze. So it's great. I had all this heat coming from the sun, but it was minus 25 outside and I was like 28 degrees inside and I was boiling. And I couldn't sleep at night. So that's the thing, right? So there's a theory. In theory, yes, I'm producing a lot of heat and it's great, but it's not comfortable, right? The only reason we do anything as humans is to really, it's for a feeling is ultimately what we're going after, right? And if we're not comfortable in our house, what's the point? So one of the things I've realized is that it is possible to overglaze. And yes, it's great if you can get that heat from the sun, but understand that you can't turn the sun off, right? The sun's on or off.
Your building is so airtight, it's so tight.
Yeah.
Did you have any problem with air quality?
No, because our ERVs, I have 2 ERVs in that system, in that house, that runs 24/7.
What was the question?
Air quality. She's wondering if I had any problems with air quality. Sorry, I didn't see who I asked that.
Could you put blinds on the windows to monitor, control the temperature?
We could. We didn't because we didn't have any rear neighbors. So that is one thing. But ultimately, what you'd want to do is have blinds on the outside because if you have them on the inside, it's already in your house. So once again, it's kind of counterintuitive. There are windows out there now that actually have a 4th pane of glass that have blinds built into them, and you can get all sorts of like solar sensors. But it's adding cost, right? So at what cost and where does it make sense? Because I got pricing for windows for that house. This was 6 years ago. My quotes range from $70,000 to $120,000 just for windows. So that's a non-starter for most people, right?
There's an old-fashioned technique, it's called shutters.
Yeah. But everybody likes simple, right? Nobody wants to have to close the shutter.
Could you do a comment on the use of spray foam insulation?
Yeah, we avoid it whenever we can. Where we use it is in renovations. So if we can design to avoid spray foam, that's what we'll do for multiple reasons. One of the biggest reasons is that's the most expensive way to insulate, and it has its places, and we think that's really in renovations. If we can design a house to avoid spray foam and actually do a better detail, like what we did by hanging our floor joists, that's what we would recommend. You have a 100-year-old house and we're trying to make it better, spray foam makes sense.
I just wondered if the three you felt a little cramped in a mere 4,000 square foot home.
Yeah, it was a little. The hallways were tight.
Maybe a way oversized house should be your third floor.
Yeah. Probably. One of the reasons we sold it. So on that note, the 4,000 square feet though, that includes the basement. So it was actually a 2,800 square foot home with a 1,200 square foot basement. So the 4,000 square feet was absolutely everything. So it was a 4-bedroom home with way too many bathrooms.
What is the total cost?
I don't know, because I ended up doing a lot of the work myself. It's not really legitimate, but I can tell you like.
How much is?
So I get this question a lot. So I wrote a blog post about this. Building custom homes is expensive. Doesn't matter if we build it energy efficient or not, it's going to cost more. And I always get the question around, well, how much extra does it cost to build a passive home or R2000 or net zero, whatever it may be? And I answer it like a politician and say, well, it really depends. Because I can build you that house, same size, same features, same energy efficiency, but I can, instead of putting masonry on the outside, reclaimed hardwood floors, concrete countertops, custom kitchen, 5.5 bathrooms, cork flooring, like instead of doing all those features, I can do vinyl siding, I can do carpet, I can do an IKEA kitchen, I can do all those things, and it drastically reduces the price, which means that the percentage that it went up to get to passive goes up. As you know, numbers being engineers, right? So it varies. But I can tell you that where you spend your money when you build a more energy efficient home, it's going to be your envelope. So your insulation, air sealing details, windows and doors, and then in theory, you can save money on your HVAC equipment, but you usually end up spending more because you put in a better fresh air system. And then you might go to like an air source heat pump for heating the house, which is about 3 times the cost of a furnace, natural gas furnace.
Casey, you do renovation as well as new construction?
Yes, most of our work is still renovations. So I know I'll be on the panel. That was the biggest, don't rely on the sun for comfort, because too hot is not comfortable.
I'm sure Casey would be very happy to give you an estimate, you know.
No, you can talk to Nick, he's over there. He'll do the estimate. We do have, the one thing I do want to point out, we do have a podcast and a YouTube channel, so check it out there. We do answer a lot of questions, we do all sorts of stuff there. If you have any questions, we're happy to throw them on there as well. If you have it, somebody else has it.